All right. So trying to get this thing into y equals mx plus b form. Okay. So there are, whenever we do this, and this is something that is going to be a fact that we need for the rest of our math lives. If I'm going to try to write an equation, there are two things that you always need. Okay. You need a slope, and you need a point that is on that line. Okay. Now there are in these cases that we show, in these examples I show, we're kind of talking about what different points they can give us and how we can maybe make our work a little bit easier based on those points. Okay. But every single line that you need to develop the equation for, those are the things that you need. Okay. If those are the things that we need, if we're going to do y equals mx plus b, okay, m represents slope, right? And this b, if you remember, that's your y-intercept, correct? Now that is a point, and it might be this point that we need, but it might not be that point we need. Does that make sense? Okay. But regardless, I should be able, given the slope and some point, always be able to generate what b is. And that's what this question is kind of targeting. All right, so as we go through this, what I need to do, first of all, first and foremost, every single time, you need to at least come up with a slope, right? Okay, so if I want to find the slope, remember that is y2 minus y1 over x2 minus x1, right? So I'm going to subtract my y's here. Don't know what just happened. Went to a completely different. Control Z. I apologize. I just jumped to a completely different section of notes. All right. We're going to take y2 minus y1. So negative 3 minus negative 2. And we'll go 1 minus 3. Okay. So negative 3 minus negative 2 gives me negative 1, doesn't it? Okay. 1 minus 3 gives me negative 2. So my slope here ends up being 1/2. Is that all right with everybody? Okay. So we've got our slope. Okay. Now, to find the y-intercept, and we can kind of make an argument about this as we look at the previous examples. In the previous examples, like example 3, it told me right here what y-intercept was, right? It tells me right there that b is 7, okay? In this question, example 4, okay, it kind of hides it a little bit, but right there, the 0, 10, if I were to graph that point, it's on the y-axis, so that's the y-intercept. So the b value there would be 10, okay? So they can explicitly give you the b value in either of those two formats, or they can hide the b value like they do here. Neither of those situations occur in example 6. They don't tell you what your y-intercept is, either through the use of the points or through just blatantly saying this is your y-intercept. Okay, so we have to be creative in how we develop that b value. Okay, so this is how we're going to do this. We know that our line is going to be of that form, right? Y equals mx plus b. Did we just find m? So I'm going to replace m with 1/2. And then I've got y equals 1/2 x plus b. Okay. Now, as we do this, if y equals 1/2 x plus b, I've got 3 variables up there, right? And I want to try to figure out what b is. So if I'm trying to solve for b, the only way that I can do that and get a number back is if I know what x and y are, correct? Okay. So there must be something going on here that we can do to replace x and y with particular values. And it comes from these points right here. Okay. You can choose, because is that an x value? So I can put that x value right there. Okay. Does that make sense? Because this rule that we're going to generate, okay, this equation that we're going to generate is going to make this ordered pair. Okay, so if we use this ordered pair to help create the equation. So that's going to be my x, and then I'm going to take this -2, and that's going to become my y right here. Does that make sense? So I'm just going to replace those things. I get -2 is 1/2, x is 3, and then plus b. And at this stage, that process right there, it doesn't tell you in words to do that, but that process is what we worked on in chapter 1 and chapter 2. Remember in chapter 1 and chapter 2, I'd give you something like 2a plus 3r minus c. And I asked you, okay, well, if a is 4, r is 2, c is 5, can you plug those in and find out what that evaluates to, right? That's exactly what we're doing here, okay? We plug in and now we can solve for b. Okay, so everything we've done in the past, there's been a reason for it, and it's to develop a skill so that we can apply it at this juncture in the course. So I get -1/2. I'm gonna multiply these together, and I get 3/2 plus b. Subtract 3/2 from both sides, so it'd be -2 minus 3/2 is equal to b. Okay, now if I'm going to subtract fractions, and I'm going to urge you to try and do the subtraction in division, multiplication, addition with fractions. Do that by hand first, okay? But if need be, grab your calculator, Desmos, and it will do the work for you, okay? So if I've got Desmos open here, okay, and either this version or if you want to use the scientific version, I'm going to use this one. We had -2 minus 3/2, right? If I just type that in, -2 minus 3/2, okay, it gives me this number here, right? Okay, now I'm going to argue to you that we do not want to leave it as decimals. So there's a button when you type this in and you get a decimal and it has the ability to change it to a fraction. That button right there will change it to a fraction. So that's what we want, -7/2. Devin. So I use the key, your question mark key puts in that right there. So it's was that a // backward slash? I don't know which one it is, but so as I hit just -2 minus and then hit my 3 and then that question mark key and it'll generate that right away. If at any time that you struggle with finding like those, so those are like hot keys on your keyboard, you should be able to come down here and it's just your division. It'll just create that fraction. But I get -7/2, so B is -7/2. Now, I show you that because I think it's important for you when you get to end of course exam to maybe use that technology, because is that going to get you results a lot quicker? Okay. But at the same time, we should be able to know that if I'm going to subtract these two things, I need a common denominator, right?
Yeah.
Is that -4/2 minus 3/2? Is this amount here still -2? That right there is still -2? So now I can subtract the numerators. -4 minus 3 is -7, and I put it over 2. There's my b value, okay? But now that I've got b, and I have m from what we found earlier, there was m, can I rewrite y equals m times x plus your b, so plus a negative number is the same thing as subtracting, right? So I'm just going to write -7/2. Okay, now I used 3 comma -2 as my x and my y. You could have used 1 and -3 as your x and y, and you would still find b to be -7/2. It's still going to work out. Okay. what I think is a good thing to do, and this is why I told you can have your computers out, is if I go ahead and graph those two initial points, 3, -2. So on Desmos, all you gotta do is open a parenthesis and then type in 3, -2. So it'll plot that point. Okay. Go down to the next one. I'll go 1, -3. Okay. There are other ways behind. Like you can create tables and stuff like that you can type in a lot of points real quick. I think that's just the quickest way to do it in Desmos. So I get those 2 points. So the equation that I developed, when I type that in, it should generate a line that creates all the other points that are in line with those two. Does that make sense? Okay, so if I type in y equals, we had 1/2 x minus 7/2, does that purple line end up going through the 2 points that we started with? And that confirms then that you have done things correctly. All right. What I need you to understand is that this rule right here will generate any one of these ordered pairs on there. Any one of them. Okay? So another way that I can check myself is I know if this rule is correct. If that rule is correct, I should be able to take either one of these points and plug that x value in. And it should spit back the y value that goes with it. So let me just see if that happens. If I go y equals 1/2, plug x in to be 1, and then minus 7/2. Well, that would be y equals 1/2 minus 7/2. Does that give me y equals 6/2? Okay, sorry, -6/2. And what's -6/2 the same as? -3. Do you see how that is the -3 that was paired with the one that I chose? That's an alternative way of checking yourself, okay? To see if your equation actually generates the y value that is coupled with the x value in your ordered pairs. If I plug 3 in there, I'll get -2 back as well. Does that kind of make sense, everybody? Okay. Now, in my opinion, the way I would do this, if I was going to check them algebraically, because I used that one there to create the equation, I would check it with the one that I haven't used. Does that make sense? Okay, because chances are if I use 3, -2 to create the equation and I use 3, -2 to check it, I would argue that there could be some issues with that and giving you a confirmation all the time that you've done things correctly. Can we do that? All right, give me, I know I didn't give you room to do this. You might have to do this in the margins or whatever. I want to do another example like that. So let's, would you guys give me a number between 0 and 8? Give me a 7. I'm gonna find that. Okay, so 7. Give me another number.
4. 8. 2.
Okay. Give me another number.
6.
I heard 2, and then I heard 5. All right. So let's find so those 2 points, 7, 4, and -2, 5. So I'm gonna plot those. 7, 4, -2, 5. I'm going to try to find the equation of the line that passes through those. Okay? Now, think about this. Just kind of visualize, putting like a yardstick between these 2 points. Is your y value going to be around 5? Is your y-intercept close to 5? Okay, so the b value that we come up with here in a little bit, hopefully is around 5. Okay? So I can kind of use that to predict what that number is going to be, which is nice. So now, again, just like the last one, I got to find the slope. Okay, and then I got to find my y-intercept, right? So my slope here, let's go 4 minus 5. And then 7 minus -2. 4 minus 5, -1. 7 minus -2, 9, right?
Yeah.
So -1, 9. So that's kind of an ugly number. Okay, as a decimal, that is as a decimal is 0.111111111 forever. Okay? Well, you can't write that in an equation, can you, as a decimal? Does that make sense? You would run out of life writing those ones, and you would never get to the point where you could write an X after it. Okay? Because that number goes on forever. So, if it was a decimal, we'd have to round it. Does that make sense? And I want to make an argument when we're done with this about that rounding process. So, what I'm going to tell you is that when you do this, do not change your fractions to decimals. Leave them as fractions. Do the work with them as fractions. Okay? So now if I go y equals mx plus b, okay, think about when we graphed these, neither of these were y-intercepts, right? Neither of those were going to produce right away my b value. So right now I got y equals m to be negative 1/9 times x plus b, right? Now we have to choose what we want x and y to be. This is an x value, that's a y value, right? This is an x value and that's a y value. Choose a group of them. And it doesn't matter, I don't think it, at least in this case, it does. I know it doesn't matter which one you choose. It doesn't make anything easier to go with the first one or the second one. A lot of times I like to choose, if this is a 1/9, I would look for, in these things, multiples of 3. And that would make things a little bit easier, but it doesn't exist here. So, let's just plug in y to be 4 and x to be 7. And we'll add b. Okay there, everyone? Okay. So it's going to give me 4 is equal to negative 7/9 plus b. I'm going to add 7/9 to both sides. And that will give me b. If I'm going to add 4 and 7/9, what do I need? I need common denominator, right? What's the common denominator going to be in this sum here? 9, right? So I need to multiply this one by 9 and multiply the top by 9, right? What's 9 times 4? 36. I got 36/9 plus 7/9, right? That's what is equal to b. So what's that? 43/9? 43/9 is equal to b. Leave it that way. Okay? 43 is a prime number, so it's not going to be divisible by 9 or divisible by 3. So that's reduced. So right now, we've got our b value and we've got our m value, right? M was this. B we just figured out to be 43/9. Can I then write y equals m, negative 1/9 x, plus 43/9? Does that make sense? Okay. Now, I know we had this situation here. If you can get to this right here, okay, can I just go to Desmos and type in 4 plus 7/9, get that number there, click that, and give me my 43/9? Okay. So you can use that. My suggestion is don't overuse that. Use it responsibly. Okay, so that you actually learn how to add fractions. So when we write this, then we go y equals, okay, negative 1/9 x plus then 43/9. Okay, does that line go through both points that we started with? Does that make sense, everybody? Okay. Now, I'm going to do something. I want to show you, just to prove a point here. So there's going to be a little bit of math here that I have to do on the side that I don't want to really spend a whole lot of time talking about. But let's say that we found our slope to be negative 1/9, right? Well, if I take negative 1 divided by 9 as a decimal, gives me something like that. Okay, now I can go and look at this and ask it to go out to 15 decimal places. But you see that thing, if I go out 16 decimal places, you can probably argue that's going to be a 1 after it, right? Okay. What if I had to round this number, maybe I write negative 0.11 as my slope. Does that make sense? I've rounded it. Okay. So now if I use that, so right now I'd have the equation y equals negative 0.11 x plus b, right? Okay. if I want to solve for b, when I use this point, what do we use? The 7, 4, okay? So I'm going to change that to 4. I'm going to change this to 7. What's going to happen is I'm going to end up adding that stuff, and that number right there is going to be my b value. Does that make sense? Okay, so if I rounded my slope, this is all I'm trying to get at. If I would have rounded my slope, the equation I get is y equals negative 0.11x plus 4.77. Okay, I get that line right there. Okay, now that line is very similar to this line. Which is what we came up with algebraically, right? Okay, and we'll make it red. Okay, so I can toggle these back and forth. You can see that they are very close to being the same line, right? And at this view, it looks like they're exactly the same line. Well, if they're exactly the same line, then 7, 4 and negative 2, 5 should both be on those lines, right? And at that view, it looks like both of those are on that line, right? Okay. Now, because I used the 7, 4 point, 7, 4 is on both those lines. Okay. But when I zoom in here, what do you start to recognize about those two lines? They're not the same. Okay. Meaning then, so this is the line, that's the actual line. That's the one we came up with by hand. This is the line that I rounded. Okay? Do you see how when you round things, you don't get the exact line that we're interested in? That makes sense? Okay? Now, the better you round, if I would have gone out to like 3 decimal places here, like a 1 there, and that would probably make this another 7 here. You see how it gets closer to B? But B is still not on there. Does that make sense? Okay, so when we are working with this stuff initially, we don't want to rewrite this using decimals because most of the decimals we come across, we're going to have to adjust them because they either don't terminate or they don't repeat. We have to round them. And when you round your slope and you round your y-intercept, you don't necessarily get the line that you're intending to get. Okay, does that make sense? All right, and I think that that's something you have to fight against because it's the way we've taught you since 3rd grade that, well, when you get a nasty fraction or a nasty decimal, round it, okay? And we're used to that, we're programmed to do that, and I want you to fight against doing that right now because of this rounding error that gets created, okay? Is that cool? Just leave things as fractions. If you struggle with fractions, like I said, Desmos is there to help. I'm here to help. Let me know if you need assistance with those types of things. We will do more examples of that stuff. Okay, we'll spend a lot of time on this, but I want to go to these special cases. Ollie.
Can we do a question like this?
We're going to get that tomorrow.
Tomorrow?
Yeah, so that assignment's not due this evening. Okay, so these are special. Yesterday we said that every single line we come across is going to be of the form y equals mx plus b, and I then started talking about as long as it's non-vertical or non-horizontal, okay? And I told you that vertical lines and horizontal lines are kind of special case scenarios, okay? So what we want to do here is it asks us to write an equation of a line that is horizontal and has a y-intercept of 3, okay? So let me just draw, just going to draw a graph here real quick. Would you guys agree the x-axis is horizontal? Okay. And actually, let's answer this question first here. It says, what is the slope of a horizontal line? Well, let's say that I've got this point here at 5, 3. And let's say we've got a point over here at -4, 3. And I asked you to find the slope of that green line. Okay? If I'm going to find the slope of that green line, don't you take that y value minus that y value in your numerator? So slope will be 3 minus 3 over then 5 minus negative 4, right? What's 3 minus 3? 0. 5 minus negative 4 is 9, right? But what's 0 divided by 9? 0. So the slope of that green line is 0. Now I'm going to ask you a question. Is that always the case? No matter where my green line is, let's say my green line is down here at like 3, negative 2, and this point over here is maybe negative 4, negative 2. If I look there, what do you get when you take and subtract the y's? What's negative 2 minus negative 2? That's 0 again, right? I don't even care what the denominator is, because 0 divided by any number is 0. So, and we talked about this previously before Christmas, but every time that you have a horizontal line, the slope of it is 0, okay? So that's nice, okay? I know for this green line, my slope is going to be 0, that's m, okay? Now I've got to find out what b is. Well, let's think about this. That point right there, because it's horizontal, that point has the same y value as that point, right? What's the y value of that point right there going to be?
3.
Yeah, it's going to be 2 comma 3, right? The y value is still 3. What's the y value of that point? 3, right? What's the y value of that point right there? The x value is 0. The y value is 3, isn't it? Is that point a y-intercept for our graph? Does that make sense? So when I go y equals mx plus b, that point right there is telling me what b is. What's b got to be in this case? B is always going to be that value there. It's 3. Okay? So when we go y equals mx plus b, y equals m, which was 0, right? Times x plus b, which was 3. Okay, we can write it that way, but that's kind of silly to write it that way, because what's 0 times x? 0. So I really get 0 plus 3. Well, what's 0 plus 3? 3. There's my equation of a horizontal line with a y-intercept of 3. Okay? Now, what if I just see what you think, or just answer what you think this might be. If I ask you, write an equation of a line that is horizontal and has a y-intercept of 7, what do you think you would write? Y equals 0x plus 7, or y equals 7, right? Okay. What if I said has a horizontal line, a y-intercept of 17? You'd write y equals 17, right? Okay. So, and it's all because each time you're going to get a slope of 0, you plug into here and all that kind of stuff. What I need you guys to understand, this says y is 3, right? That's what equals means. It means the word is, correct? Whenever I look at a line like y equals 3, and I look at any point that is on that line, do you guys agree that A is on that line? And here's the ordered pair for that. No matter where I move A, what's the y value? 3. Do you see how our rule is telling us what y is? Y is 3 no matter where that thing goes. Okay? And my x's, does it matter what my x's are? No, because I can traverse all x values that ever existed. Okay? And if I get down to that x value right there, what's the y value that goes with it? 3, right? Okay? Give me, we'll do it this way. Let's go. It'll just make things a little bit easier. F of x equals 3. If I write it this way, instead of y equals 3, write it as a function. Give me, let's say x is some number. Give me some number that I want to type in here. You just start randomly giving me some values here. 4, I heard 6. Give me another number. 7, 8, 9, 10, 11,
12,
12,
13.
13. Okay, so if we go out to that number on the x-axis, okay, what we're going to find out is that when we graph that, it's going to give me a y value of 3. Does that make sense? Okay, so there is an ordered pair of this number. See if I can control C. See if we can actually plot that number. Control V, comma 3. If I go out to that, okay, I'm gonna zoom out real far. Real far. What we got? 1, 2 billion, trillion. Should be getting there. Trillion. Come on. Wow, I just ran out of the capability. It keeps going back. I think I run out of the capabilities of GeoGebra. But if we were able to go out to that number on the x-axis, okay, on that green line, there's going to be a point on that green line at 3. Does that make sense? At a y value of 3. Okay. So it doesn't matter what your x value is. Your y is always 3. Okay. Now, let's do this. Because it's a little bit different when we talk about a vertical line. If I talk about a vertical line, when I talk about a vertical line, let's say we have a point like 2, 3, and a point like 2, -4. Okay, and I asked you to find the equation of that line right there. Well, to find an equation of a line, I need m, right? Let's go ahead and find m of this. I go 3 minus -4 over 2 minus 2, right? We get 7 over 0. What's 7 divided by 0? Undefined. Okay? Meaning it doesn't exist. It's not a number. Okay? So if it's not a number, and this is where things get a little bit confusing, if it's not a number, then I can't multiply it by x, which is another number, and know what that is. Does that make sense? Okay? So I can't use this format. Okay? In addition, b is a y-intercept, correct? And y equals mx plus b form, b is a y-intercept. Does that red line ever cross the y-axis? No, it's parallel to the y-axis, right? It's vertical. Okay? So this doesn't work. This doesn't work. Okay? But maybe an argument that we made about what we talked about here, that no matter what point I choose on here, on this green line, y is 3, right? Come down here to this red line. No matter what you choose, no matter what point, okay, do you know what the x-coordinate of that point right there is? That point right there. What's the x-coordinate for it? To go from 0, 0 to that, I've got to go over 2, don't I? Isn't that distance always 2? So that point right there is 2 comma something. What about that point right there? How do I go from 0, 0 to that point? How far over do I have to go? I have to go over 2, right? What am I seeing about every single one of these points on that vertical line? The x value is what? The x value is 2. So if the x value, just like we did up here, y is 3, here, x is 2. Does that make sense? And there's your rule for writing the equation of a vertical line. Okay? So if I told you, find, and here, I know I didn't answer the questions being asked here. Here it says you have an x-intercept of -5. So if I were to come over here, it's saying that my line is going to pass through that point, and it's going to be vertical. So I'm looking at that dotted line. What would be the equation of that dotted line? What is that x value right there of that point? Careful. -5. What is the x value of that point? Negative 5. What's the x value of that point? Negative 5. What's the x value of any point on there? So when it's vertical, the equation of that would be x equals negative 5. Okay? So the conclusion, kind of wrapping this all up into a nice little statement that we can use to help us quickly come up with the equations of vertical and horizontal lines, is this. It says when writing the equations of a vertical or horizontal line, identify which axis the line is going through. Identify the axis that the line is going to pass through. So if it's horizontal, it's going to pass through what axis? The y. So that's then the letter you choose. Okay, so if it's horizontal, I'm going to choose y. If it's vertical, what axis does it pass through? X. So if it's vertical, I choose x. Then I write equals, and then the number that those lines are passing through on those respective axes. Okay? And the idea here, I'm not going to draw this picture out again because we did it up here, but the idea is no matter what vertical line I draw, right? Oh, that's terrible. No matter what vertical line I draw, like that one there, okay, is the x value on that vertical line, I know you might not go see it, but is it 6 all the time, no matter what point? Yes. Okay. And that helps us, I know it passes through the x-axis, so I write x, and then the value right there that it passes through is 6. So x equals 6 is the equation of that line. And we do the same thing, if I do up here, okay, that's going through 9. There I'd write y equals 9, because no matter what, the y value on that line is always 9. Is that something we can do? Okay, that, to be, in my opinion, that's one of the easier things that we do all year. But it's so simple that people struggle with and they mess it up all the time. Okay? So just be careful with that. All right, so you guys have been asking, about questions out of the homework for graphing things. Okay? Tomorrow, first thing, initially, we're going to graph things, but in order to do that, we need to be able to pull off the slope and the y-intercept out of any equation that they give us, okay? And they're going to give us equations that are in nasty formats. So what we want to first do is transfer everything over into y equals mx plus b format. You guys remember early on, chapter 2, maybe I gave you something like 2a plus 3b equals c, and I asked you to solve for a. And you had to go, okay, isolate A, so it's going to be 2A equals C minus 3B, and now divide everything by 2. So we get C over A minus 3B over A. Remember doing that? Okay. The reason we did that was so that we could come over here and do that stuff right here, because we need to solve for Y. At this stage, it's actually easier than what we did in chapter 2, because it's only going to be 2 variables. It's always going to be X and Y. That's it. Okay? But when we want to be able to graph these things, we need to put it in y equals mx plus b form initially. So if I want to get that y by itself, what do I need to do to both sides of this equation? Add 2. Now, when I add 2, are 3x and 2, are they like terms? No. So I can't really condense them or combine them into one term. So we should rewrite it as negative 3x plus 2. Once you have it in that form, what's m in that case? What's my slope? Negative 3. And my y-intercept is 2. Okay. What about this one? What would I do to solve for y right there? Add 9x, right? So I get y equals 1/2 plus 9x. Now I'm a fan of rewriting it this way because the commutative property is available to us. Is that the same thing? What's my slope there? 9. What's my y-intercept? 1/2. Is that okay with everybody? All right. Let's come down. Let's do one more here. Or actually, we'll do 2 more. But I want to skip this one first. Let's do this one. How do I get y by itself there? Okay, so I get y minus 1/2 x plus that 0 there, right? Does that make sense? Okay. What's my slope there? And what's my y-intercept? 0. Okay, here's my question. If I gave you 3 and asked you to add 0 to it, is anybody going to write 3 plus 0?
No.
You're going to write 3, right?
Yeah.
If I say 1/2 x or negative 1/2 x plus 0, are you going to write that plus 0 with it? No. So most of the time, you're going to see this equation written that way. And there's no plus or minus behind it, right? Well, then that means because there's no plus or minus, then that means you pass through the origin, 0, 0. Your y-intercept is 0. Does that make sense? Okay, so if it's not written, y-intercept is 0. Okay? Now, this one's a little bit more difficult. Okay? What would you guys do in this one right here first? Distribute. So I'm going to get negative 2y equals 30 minus 18x, right? Now what would you do to get y by itself? You could add 18 to both sides, but that's not going to get y by itself all by itself right away. Divide by negative 2. So I'm going to divide by negative 2. Okay, so now when I do this, remember, when you divide the right-hand side by negative 2, you're dividing everything over there by negative 2. So what's 30 divided by negative 2? Negative 15. What's negative 18 divided by negative 2? Positive 9. Remember, a negative divided by a negative turns into a positive. Now, is that y equals mx plus b form?
No.
Makes sense maybe to reorganize it, right? Write it as 9x minus 15. So now what's your slope? 9. What's the y-intercept? Negative 15. So those guys, those are the things. So when you guys are asking questions about, you know, how do I graph something like this? Tomorrow, the first thing we will do is say, okay, what is my slope? On that example, what's my slope? 2. What's my y-intercept? Negative 1, right? We'll need to identify that stuff first before we get to any process of graphing. Okay? Because those are essentially the strategy or the tools or the set of directions that we use to actually get our line.
So, the due date on the homework is today, right?
Yeah, I'm going to move it back. So, at the earliest, they'll be due tomorrow night. But I'll probably make it the following night.
Well, there's 24 questions.
Huh?
24 questions.
24 questions.
Yeah, I only did 6 because I got stuck on this.
So all the graphing ones, guys, if you see a graph right away, just skip it because you're not going to be able to do it yet. We're going to hash out, and this graphing stuff, guys, it's pretty easy. It's not something that you guys are going to struggle with. If you can follow the set of directions, you're going to be fine.